Okay, so we'll consider it to be example 1. You can quickly pause the video and have a read through the question. Okay, so the first thing to do, like with almost any mechanics question, is to draw a diagram. So here's my diagram, there's my rough floor, my rod, A on the floor, B here, resting on a smooth peg C, 15 degrees. Okay, so that's it. And now we're going to put forces on our force diagram. So I'll do these in blue. So what forces have we got? Well, we've got the weight of the rod, which acts at its midpoint because it's uniform, 40 g-newtons. We've got a reaction force where the rod touches the ground. We've also got a reaction force where the rod leans on the peg, and this acts perpendicular to the contact, so it acts perpendicular to the rod. And finally, we've got friction. Now, when you're deciding which way friction's going to go, left or right, we know that it's in equilibrium, and this reaction at C is acting to the left, which means that friction must be acting to the right. So we'll label this one as mu times Ra. So that's our force diagram. You might also add on this and this, and both of these angles are 15 degrees. Okay, so part A is to find the magnitude of the reaction at C. So if you think back to what I said a minute ago, there's always three things to consider in these questions. You can do up forces equal down, left equals right, or take moments about a point. So if we just think about those three options, if we do up equals down, then up we've got RA plus RC cos 15 equals 40G. That has two unknowns, RA and RC. If we were to do left equals right, we'd have mu RA equals RC sine 15. That actually has three unknowns, mu, RA and RC. So the best course here is to take moments, and if we take moments about A, then we can actually ignore both these forces that act through A, and we're actually going to get an equation in just one unknown. So, taking moments about A. So remember, a moment is a force times perpendicular distance. So the clockwise moment about A, we've got the force of 40G, and the perpendicular distance to this force is 5 meters cos 15, because we need the distance along the floor, so perpendicular to the force there. So 5 cos 15, and that needs to equal, because it's in equilibrium, this one, the force is RC, and the perpendicular distance here is actually just 8 meters along the rod, so RC times 8. And from here we can see that RC is just going to equal the left hand side of that equation divided by 8, which is 236.7 newtons. So 240 to two significant figures. Okay, and part B then says the coefficient of friction between the rod and the ground. So here we're just going to draw in the other elements, doing up equals down and left equals right. So if we start with up equals down, then we can see that acting up we've got RA plus RC cos 15, and acting down we've got 40G. Now we know the value of RC from above, so if we do 40G subtract answer times cos 15. We see that the reaction at A is 163.4 newtons. And now if we do our horizontal forces, we can see that mu Ra equals Rc sine 15. So if we just put in our values from above, we get a value for mu of 0.37 to two significant figures. There we go, and that's our first example done. That's a pretty typical example, so hopefully that makes sense to you. We'll look at a slightly different one next.